Hi Math 1 students. Mrs. Robinson here to work practice benchmark chapter 3 with you. So let's go over some of these problems. First, we're going to find the slope of each line. Remember, slope is rise over the run or change in y2 minus y1 over x2 minus x1. Meaning the rise, if you rise up, you would find the difference between the two y points. And if you run over, you would find the difference between the two x points. So let's start at a point, pick a point, and how much do you rise up? Just count it. You rise up 1, 2. So the rise would be 2. And you run. Now, normally when you rise, you would run to the right. This time we run to the left, or I call it run back, which means that's in the negative direction. So I'm going to go back 1. Or you can think of it like this. Start here, and instead of rising, you fall 1. Or excuse me, you fall 2 and go to the right 1. So here I have a negative slope, and the slope would be 2 divided by negative 1 or negative 2. There's my slope. Now, just a reminder, if you're not sure what your slope, if it's positive or negative, you can remember by doing your little buggy. If your little buggy tries to drive uphill is positive. If your little buggy drives downhill, it's negative. And I have a downhill here, so I know I have a negative slope. If your little buggy tries to drive, there's my little buggy, on flat ground, it's zero slope. He's not going up or down. And if your little buggy tries to drive straight up this wall, so for the vertical line, this is undefined slope, okay? Meaning I can't drive straight up a wall. It's undefined unless you're SpongeBob or some weird thing under the water. So this is undefined slope. So uphill, this would be positive slope. Downhill, negative slope. Flat ground, zero slope. Up a wall, undefined slope. Okay, so let's look here at the slope. We need to find 2 points so we can find the slope. This doesn't cross right on the grid anywhere, but this point does. So I could use this point right here, or really any point that crosses right at intersection, right on the grid. This point would work, or this point would work. So start at a point and count up and over. So I'm going to count up 1, 2, 3, and over 1. So I rise 3. I run 1. So my slope here is 3. All right, let's go ahead and find the slope passing through 2 points. So number 3, if I find a slope passing through 2 points, I'm just going to use slope formula. Slope is y2 minus y1 over x2 minus x1. So label your points. This could be x1, y1. This could be x2, y2. And just go ahead and do it. y2 minus y1, so I'm going to go negative 4, careful of double negatives here, negative 4 minus 3, and then do x minus x, negative 2 minus 5. And just do the math on that. You've got, let me erase this. Okay, negative 4 minus 3 is going to be negative 7. Negative 2 minus 5, that's also negative 7. Negative 7 divided by negative 7 is positive 1. So the slope for number 3 is positive 1. Let's look at the slope for number 4 passing through these 2 points. So I'm going to go y minus y, 5 minus negative 3. Careful of the double negative, y minus y. If I start here for the y's, I start here for the x's, over x minus x. So 6 minus 1. Double negative makes a positive, so 5 plus 3 is 8, and 6 minus 1 is 5. So the slope here is 8/5. Rise 8, run 5. All right, let's look at number 5. We need to state the independent variable and the dependent variable and find the rate of change. Remember, rate of change is just the slope. Let's look at this. What is independent and what is dependent? Jack's filled 10 envelopes in 1 minute and 100 envelopes in 10 minutes. Okay, so, all right, 5 and 6, state the independent variable and the dependent variable. Find the rate of change. So, rate of change, come on, pen. Rate of change, dependent, independent, okay? Jack's filled 10 envelopes in 1 minute and 100 envelopes in 10 minutes. So I can already tell you what the rate of change is. It's like the unit rate. It's going to be 10 envelopes per minute without even knowing this. But let's go ahead and identify things. You have your X and Y. Y always depends on X. When we write things like this, right? I pick something for X, I do this to it, and I get out Y. So Y is always our dependent, and X is independent. Okay, I pick what I want for X. So look here, I have envelopes per minute. I stuff 10 envelopes in a minute, 100 envelopes in 10 minutes. So the amount of time I take is going to be independent. I'm going to pick that amount of time. So this will be my independent, my time. Okay, that says time. And my dependent will be the number of envelopes I get to do. That depends on how much time I do. So my dependent will be envelopes. Okay, so make sure you tell me time is your independent and envelopes is your dependent. All right, now let's go ahead and look at, for time, we're going to go 1 minute and we do 10 envelopes. Or we do 10 minutes for 100 envelopes. You can get the rate of change just by doing slope. Y minus Y over X minus X. So 100 minus 10 over 10 minus 1. Y minus Y over X minus X. That's just going to be 100 minus 10 is 90. Divided by 10 minus 1 is 9. 90 divided by 9 is just going to be 10 over 1, or 10 envelopes per minute. So the rate of change will be 10 envelopes per minute. And there you have it. And that was really right there. So let's look at number 2. We're going to do the same thing here. We have 2 pounds of apples that cost $3.98. 6 pounds costs $11.94. So the number of pounds and the cost, which one's dependent, which one's independent? Well, I'm going to pay a certain amount depending on how much I buy, right? So the cost is going to depend on the number of pounds I buy. So let's look at this. Cost in pounds, or the number of apples, all right? 2 pounds of apples. So the number of pounds is going to be your independent. I pick how many pounds I want to buy. Equals pounds of apples. And then my dependent, the cost depends on the number of pounds I buy. It's going to be the cost. So you can look here, the number of pounds, 2 pounds, and I get a cost of $3.98. Okay, 6 pounds, and I get a cost of $11.94. So how do I find the rate of change? Go Y minus Y. You're just going to go $11.94 minus $3.98 over X minus X, 6 minus 2. Go ahead and do the math on that. All right, so if I subtract these, I get $7.96, and then 6 minus 2 is 4. Now, when I do the rate of change, I want this to be a unit rate. So I'm just going to go ahead and divide top and bottom by 4. And that's going to give me $1.99 for every pound. So what's the cost, or the unit rate would be $1.99 a pound. So I'm going to say $1.99 per pound. All right. So just go ahead and find the slope, really. Just do Y minus Y over X minus X, and then go ahead and convert that to a unit rate. Okay, if I want to find the constant of variation in a direct variation, remember with direct variation, Y varies directly with X. Basically, Y is something times X. It really is the same thing as slope-intercept form, where that constant would be your slope, and then your y-intercept would be 0. So a direct variation is an equation of a line that goes through the origin, right? Goes through the origin, either positive or negative, because your y-intercept would be 0. So that's a little connection between that. What I have here is, what is my constant of variation? So I need to put it in this form. I'm just going to go ahead and get y by itself here. So to get y by itself, I'm going to divide both sides by negative 36. By negative 36. Okay, and I'm going to get y equals to, when I divide 12 by 36, 12 goes into 36 3 times. So I'm going to get negative 1 over 3, and that will be times x. Now I have y equals something times x. I can flip that around so it looks like this. Just flip this around, you'd have y equals negative 1/3 times x. So that constant of variation is just 1/3. Excuse me, negative 1/3. All right. So just get it to look like this. All right, y varies directly with x. So remember, y varies directly with x, something times x. Okay. And then they say y is 792. 7.92, not 792, 7.92, when x is 2.2. So if I know y and x, I can figure out my k. So I'm going to go ahead and do that. And then I can go ahead and figure out y when x is 8. So first figure out your constant. I'm going to divide both sides by 2.2. And my constant will equal, let's go ahead and go 7.92 divided by 2.2 on a calculator. My constant of variation is 3.6. So now I know exactly how y varies directly with x. Y is equal to 3.6 times x. So now it says find y when x is 8. So I just go, well, y equals 3.6 times 8. 8 times 3.6 is 28.8. So y will equal 28.8. There you have it. All right, guys, let's look at number 9. Find the slope and y-intercept of the graph of each equation. Well, all you really need to know is slope-intercept form, y equals mx plus b. So it doesn't tell me to graph. It just says find the slope and y-intercept. So if you are in this form and you are solved for y, the number, the constant next to your x is your slope. So I am in this form. This constant is my slope. So my slope is equal to 6, or 6 over 1. So you would rise 6 and run 1. And then my y-intercept is always my b value. Okay, so that's going to be 11. So if I were to graph this just to sketch it, my y-intercept is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. And my slope is 6 over 1. So I'd go up 1, 2, 3, 4, 5, 6. I go up 6 and I go over 1. And I create a line. All right. It doesn't ask you to graph. It just asks you for the slope and y-intercept. Okay, let's go ahead and look at number 10. The slope and y-intercept. Remember, y equals mx plus b. The value next to the x is the slope. Well, nothing is written there, and a lot of times I get students go, oh, well, the slope is 0. No, if the slope was 0, 0 times x makes 0. If the slope was 0, I'd have y equals to 6. Remember, when the slope is 0, you're on flat ground. That's a y equals to line. The slope here is not 0. The slope is 1. So your slope equals 1. Okay. Your y-intercept here, your b is 6. Slope is 1. Intercept is 6. All right, we're going to write our equation in slope-intercept form. Y equals mx plus b, that's slope-intercept form. Okay. They give us 2 points. So the line goes through these 2 points. I can get a slope off of these 2 points. I go, so just to recap, in order to put it in this form, I need a slope and I need a y-intercept. So I can get a slope right away just by doing y minus y, so 7 minus negative 1, double negative there, and then x minus x. So I'm going to go negative 8 minus, and then also double negative. So careful of the double negatives. This becomes positive, and I get 7 plus 1, which is 8. This becomes positive, and I get negative 8 plus 4, which gives me negative 4. And then this reduces to negative 2. So my slope I have. Now I need my y-intercept. Now you can use point slope form here and go y minus y1 equals m times x minus x1. I just like to find the slope, and then I pick one of these points. I pick one of these points. Either one they'll both work. Just pick one and plug it in for x and y. Remember, these are xy points on your line, so you can pick either one. So I have this. I have an x and a y. I just plug them in so I can figure out what b is. So my y is going to be -1 equals my slope is -2. My x is -4. And now I can figure out what b is. So I'm going to go -1 equals -2 times -4 is +8 plus b. I don't know what b is still. Subtract 8 from both sides, and you're going to get -9 equals b. Now I have my b, and I have my m, and I have my equation. So now I'm going to write it over here because I wrote so big I took up everything. Y will equal my slope, which will be -2 times x, plus my y-intercept, which is -9. So instead of writing plus, I'm going to write -9. So there is my equation. Okay, let's do it again over here. I want to be in slope-intercept form, y equals mx plus b. You can use this, guys. Y minus y1 equals your slope times x minus x1. You can use this if you have a point and a slope. And then once you're done with this, you pick your y point or your xy point. You plug this in here and here, and you get your slope. Then you'd have to solve for y to get it into this form. That's why I don't prefer point slope form. I think slope-intercept form is the best form. It's your graphing form. So I'm just going to go find my slope. My slope is going to go y minus y, 2 minus 6, over x minus x, -4 minus 4. So my slope is going to be 2 minus 6, which is -4. -4 minus 4 is -8. Reduce this. This is going to reduce to 1/2. So I have my slope. Now I need my y-intercept. Well, I can't get that unless I use an xy point. So I'm going to pick either of these. Pick this. Here's your x point. Plug that in. Here's a y point. Plug that in. Now you have three things and you can solve for this. So I'm going to go, well, 6 equals 1/2. And then my x point is 4. 1/2 times 4 plus b. Solve for b. 1/2 of 4 is 2. So 6 equals 2 plus b. Subtract 2 to both sides. You're going to get 4 equals b. So if 4 equals b, now you have everything you need. Just write the equation. Y equals 1/2 times x plus 4. So your y-intercept is 4. Your slope is rise 1, run 2. Now let's do some graphing. So number 13, we're going to graph y equals -2/5 x minus 5. It's in slope-intercept form. It's the form I want. Here's my slope. Here's my y-intercept. Okay, so I start with my y-intercept. I go on, this is my y, this is my x. I go on my y-axis and I find where x is 0. Gives me my y-intercept of -5. 1, 2, 3, 4, 5, right there. There's my y-intercept. And then I use my slope to count to find another point. My slope is -2/5. So what that means is you could have -2 over 5, or you could have 2 over -5. These are equivalent. So pick. If I have -2 over 5, remember I normally rise over run. That means rise up, run to the right. But if I have a negative, I say fall and then run. So you're going to fall 2, 1, 2, and run to the right 5. 1, 2, 3, 4, 5. All right. Now, if you want to use this is positive. So this would be rise. And then that's negative. So that means you're going to run, but you're going to run left. Okay. Or run back because it's negative. So you rise 2 and run back 5. 1, 2, 3, 4, 5. And there's your points. Right? Either way, you only need 2 points to draw the line. I like 3 points because I can just be a little more accurate, but make sure you draw your line. And then you look, you had negative slope. So remember, if you drive your little buggy downhill, it's negative slope. So double check your slope that way. All right, there's your line. Let's go on and look at this one. Now this one is not in slope-intercept form. You can actually get the slope off of this because here's your slope right here. This is in point slope form, y minus y1 equals your slope times x minus x1. So because you're in point slope form, you can graph this way. Get your point. Here's your point here and here. It's opposite of this, opposite of this. So my point would be -4, +3. There's my point. So I'm going to go -1, 2, 3, 4, +1, 2, 3. There's my point. And then my slope is -2. Remember, if you don't have a denominator, put it over 1. So that means I fall first, then run 1. Fall 2, run 1. You can do it again. Fall 2, run 1. Fall 2, run 1. And there is your line. Okay, if you're in point slope form, you can easily graph without changing to slope intercept form. Okay. If you're not a fan of point slope form and you're like, I forgot it's opposite this, opposite that, well, just change this to slope intercept form. Change it to your graphing form. Do that by just solving for y. So distribute to both sides. This would be -2x, and this would be minus -2 times 4 is -8. So you get y minus 3 equals -2x plus 8. Solve for y. Add 3 to both sides. Okay, and I'm going to write this up here. Y is going to equal, that eliminates, -2x, and then -8 plus 3 is going to be -5. So your y-intercept is -5. Let's check and make sure it's the same graph. Go down 1, 2, 3, 4, 5. Ding, 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 ding. Look, we hit the same point. Our slope is -2. Look, we have the same slope. Our slope is -2. That means I fall 2, run 1. Or, remember, -2 over 1 is the same thing as 2 over -1. These are both -2. Okay? I could rise 2, go back 1. Rise 2, go back 1. Rise 2, go back 1. So look, it's the same line. Okay. So if you want to put it in slope-intercept form, or if you're friendly with the point slope form, y minus y1 equals m times x minus x1, you can use your point, opposite, opposite, and a slope to graph. Y-intercept gives you a point, it gives you the y-intercept and a slope. So you just need a point and a slope in order to graph. Start at your point. From that point, count your slope. All right, let's look at number 15. Find the x and y intercepts of the graph of each equation. Okay, remember, I'm going to just look up here. Remember, x and y intercepts. This is your x-axis, this is your y-axis. If I have an x-intercept, let's say here, okay, this is the point over 3 up 0. So this is the point 3, 0. It's an x-intercept. It touches the x-axis. Remember, whenever I have an x-intercept, the y value is 0. Okay. If I had a y-intercept, let's say here, up 1, 2, 3, 4. The y-intercept, I go over 0, and I go up 4. So remember, anytime you have a y-intercept, your x is 0. So to find x and y-intercepts, x-intercept, you plug 0 for y. Okay. Or, and then for the y-intercept, you plug 0 for x. And that's all you have to do. So let's go ahead and do that. Find the x-intercept. I'm going to plug in 0 for y. Okay. I plug in 0 for y. I'm going to get x equals 3 times 0. Oh, not x equals. I lied. You're going to get x minus 3 times 0 equals 9. Well, 3 times 0 is just 0. So x equals 9. So what's the x-intercept? X equals to 9. I will also take this. You plugged in 0 for y, so the point would be 9, 0. Okay, so x equals to 9 or 9, 0. Okay, for the y-intercept, I plug in 0 for x, so this would look like this. 0 equals -3. Oh, I did the equals again. It doesn't say that. 0 minus 3 y equals 9. So I plugged in 0 for x. Now I got to solve for y. Divide both sides by -3. Y equals 9 divided by -3 is -3. There is your y-intercept. Remember, y-intercept, I plugged in 0 for x, so it's the point 0, comma, -3. I will take this or this. So if you want to tell me the y-intercept is -3, the point, I didn't put parentheses, sorry, the point is 0, -3. Okay? Do not do this. I get this a lot, and I will mark this wrong. Your x-intercept is 9. Your y-intercept is -3. And sometimes students will write this, oh, 9, -3. This is not true. If I have an x-intercept of -9, I'm on my graph, or excuse me, an x-intercept of 9. I'm on my graph over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 0. There's my x-intercept. My y-intercept is -3. It's on the y-axis. 0, 1, 2, 3, right here. Those are my x and y-intercepts. It is not the point over 9 down 3. That's this point over here. Do not put these together. Okay, if you want to make an ordered pair, it's 9, 0 and 0, 3. Okay, let's do the x and y-intercepts here. X-intercept, I set y equal to 0. Okay, remember? So I'm going to come up here and y is equal to 0. 2x minus 3 times 0 equals -6. 3 times 0 is just 0, so I'm going to go 2x equals -6. Divide both sides by 2. X is going to equal -3. Okay, so there is my x-intercept. I had y equals to 0, so it would be -3, 0. This is also functional. Let's go y-intercept. Y-intercept, x equals to 0. Okay, so I come up here, x is 0. So I'm going to go 2 times 0 minus 3y equals -6. That goes away. I just get -3y equals -6. Divide both sides by -3, and you're going to get y equals to -6 divided by -3 is 2. So there's your y-intercept. Remember, x was 0, so it's the point 0, 2. So either of these work. All right, so either tell me the x-intercept is -3, the y-intercept is 2, or tell me the x-intercept, the point is -3, 0, the y-intercept, the point is 0, 2. All right, on to 7. Okay, look, 17 told me to graph using x and y-intercepts. This is this equation right here, okay, 2x minus 3. So we just did that one, and remember our x-intercept, sorry, hold on. Our x-intercept was -3, and our y-intercept was 2 here. So remember, -3, the x-intercept is -3, 0. That's the point. And the point here is 0, 2. So just graph these. If the x-intercept is -3, I'm going to go -1, -2, -3 right there. And the y-intercept is 2. I'm going to go on the y-axis up 1, 2. Okay, so it's over 0, up 2. And bam, there's your line. That's all you have to do. All right, let's look at this one. This is not the same as this one, so we have to find the x and y-intercepts. To find the x and y-intercepts, remember the x-intercept, I plug in 0 for y. So if y equals to 0, this is going to be -3x. I'm plugging in 0 for y, and when I do that, that goes away. So -3x equals 12. Divide by -3. And x is going to equal -4. Okay, so remember the y is 0. Here's your x, here's your y. The x-intercept is at -4, -1, -2, -3, -4, right there. Now let's find the y-intercept. Okay, so the y-intercept, x equals 0. So I'm going to come over here and make 0 for x. If 0 is x, this whole thing goes away, and I'm left with -6y equals 12. Then divide by -6 on both sides, and you're going to get y equals 12 divided by -6 is going to give you -2, and I'm going to go down 1, 2. There you have it, and you're going to go ahead and connect, and there's your line. All right, guys, I didn't make that very pretty, did I? All right, graphing horizontal and vertical lines. Graphing x equals to 2 and y equals to 7. Okay, remember with the x equals to, think of it like this. Go to your x-axis. This is how I always remember. Is this a horizontal or a vertical line? Well, where is x -2? -1 right here. Here's x is -2. It doesn't matter what y is. X is always -2. So y could be up here at 1, x will be -2. Y could be 2, x will be -2. Y could be negative whatever this is, -10 or -8. Y would be -2. Or excuse me, x would be -2. So it doesn't matter what y is, x is always -2. And here you have it. Okay. Remember the slope here is undefined. And if you look at this, this is the only time I can't write y equals mx plus b form. Okay, because I don't have a y. This isn't even a function. So there we go. All right, let's look at this. Y equals to mx plus b. I can write it in this form. If you'll just look, I don't have this part. That's because my slope is 0, and this goes away. So remember, 0 slope is that flat line. So where's y7? Go on the y-axis. Here's your y, here's your x. Go on the y-axis to where y is 7. 1, 2, 3, 4, 5, 6, 7. Y is always 7. X could be 1, y is 7. X could be 2, y is 7. Y is always 7. This is where y is always 7, right here. Okay, so go where x is, always -2, and make the line. Here, go where y is always 7 and make your line. So y equals 2 is going to be that horizontal line. The slope is 0. X equals 2 is going to be that vertical line. The slope is undefined. Let's go ahead and look at 21. Write an equation of a line that passes through this point and is parallel to this graph. Parallel and perpendicular lines. Remember, if two lines are parallel, they have the same slope. Same slope. Okay, that's because they're going to have different y-intercepts, but the same slope. I'm going to go up and over, up and over, up and over, rise over run, rise over run, rise over run, rise over run. It will be the same when the lines are parallel. When lines are perpendicular, they have opposite reciprocal slopes. So this is a positive slope, this will be a negative slope. Okay, and these two are vertical, and so for example on this one is a vertical line and this one is a horizontal line. So this would be undefined slope and this would be 0 slope. So 0 and undefined slope are perpendiculars. Or if you had something slanty like this, okay, these are perpendiculars. So you would have a positive slope and a negative slope. So perpendiculars are opposite reciprocal slope. Okay. Parallels are the same slope. Opposite reciprocal slope means if one slope is 2 over 1, the other slope is -1/2. If one slope is -3, the other slope would be +1/3 because this is 3 over 1. Okay, so they asked us for parallel slopes, which means I have the same slope. Parallels have the same slope. So if it's parallel to this graph, that means the slope's the same. And here's my slope. My slope equals 2. If it was perpendicular, my slope would be -1/2. So I'm going to use that slope because they're parallel. And then I'm going to use that point. So I'm going to go like this. If y equals to mx plus b, I need to figure out my m and my b. I know my m, it's 2. It's the same as this line. And I can figure out my b with this point. Plug this in for x, plug this in for y. So -1 equals, my slope is 2, times my x point, which is -4, plus b. Now just solve this. So let's move this over here. This would be -1 equals 2 times 4 would be -8 plus b. And to finish solving this, I'm just going to add 8 to both sides. And then that will give me 8 plus 8 is 0. And the -1 plus 8 will be 7 equals b. So I figured out my b. I figured out my slope. Write your equation. Y equals 2. Your slope is 2 times x. And then your y-intercept is 7. So remember, put it in this form, y equals mx plus b. Your m was 2, your b was 7. So anytime you're asked to write an equation, what you need to know is your slope and your y-intercept, and you can write any equation, okay? You knew your slope, you had to use these 2 points and your slope to get your y-intercept. Oh, okay, I have to do 22 again because I just didn't hit record while I was doing this. Okay, we have to figure out if it's parallel, perpendicular, or neither. So remember, parallel. Parallel lines have same slopes, so same. Perpendicular. Perpendicular lines have opposite reciprocal slopes. Okay, and neither have the same or opposite reciprocals. They may be skewed, like 3 and -5 or something. I don't know. So we got to figure out the slopes of both of these lines. Now remember, if you're in y equals to mx plus b form, it's so easy to see the slope. It's the number next to the x, but y has to be solved for. Equation 1, I see the slope right away. It's in slope-intercept form. So for equation 1, the slope is -6. Equation 2, I am not in slope-intercept form, so I got to get in this form so I can figure out what the slope is. So I got to solve for y. So I'm going to come over here and add x to both sides. I don't know why it gives the cross when I do that. All right, bring down 6y, bring down the equals. I'm going to write the x first because when we write slope-intercept form, the x usually we write first. So x plus 12. That's what's on this side. Now solve for y, divide both sides by 6, and you're going to come up. Excuse me. 6 equals 6 into x, or 1x, would just be 1 over 6x. And you can't really see that because I wrote into the writing. Let me write that again. 1 over 6 times x. And then 6 into 12 will be plus 2. So here is equation 2 when I've solved for y. The slope is the number next to the x. So equation 2 has a slope of 1/6. Are these the same slope? Nope. Are they opposite reciprocal slopes? Well, I think they are. That's positive, that's negative, or excuse me, that's negative, that's positive, and they're reciprocals of each other. This is 6 over 1, this is 1 over 6. So ding, 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 these are perpendicular. Okay, so check the slopes. Check the slope. That's what I want to say. Check the poo. Okay, write an equation of a line that passes through the point -5, -6, and it's perpendicular to this equation. Okay, perpendicular means opposite reciprocal slope. So I gotta find the opposite reciprocal slope to this line. Okay, if it's perpendicular to this line. So first I gotta find this line's slope. So I'm gonna subtract x to both sides, and I'm going to solve for y. So y is going to equal to 6 minus x, or I'll write -x plus 6. That's positive, that's negative. So my slope, remember, slope-intercept form, y equals mx plus b. Okay. The slope is the number next to the x. It's a negative, which I write as a -1. So I figured out my slope already. It's -1. That's the first step. Now I got to figure out my y-intercept. What is that? Okay. Sorry, my slope is -1. That would be if these lines were parallel. They're perpendicular. I need the opposite reciprocal slope. So if -1 is my slope, the opposite reciprocal would be +1, and I'd flip it over 1. Well, 1 over 1 is just 1. So the opposite reciprocal slope is going to be +1. So my slope is +1. And there we go. My slope is +1. Okay, so I found the slope. The slope was -1. And then I knew I needed the perpendicular. So I took the opposite, which instead of negative, it's positive, and the reciprocal, 1 over 1, which is 1. Now find y-intercept. Well, they give me point -5, -6, and I have a slope 1. So I can find the y-intercept. Plug in 5 for x, and it's -5. And plug in -6 for y. So you're going to go -6 equals 1 is my slope, not -1. 1 times x, which is -5, plus b, and solve for b. So -6 equals -5 plus b. Add 5 to both sides. And you're going to get -6 plus 5, which is -1. And that will equal your y-intercept. You got your y-intercept, you got your slope, you got an equation. You just need slope and y-intercept. So write it. Y equals 2. Your slope is 1, which you can just write as 1x, or you can just write x, plus your y-intercept is -1. So your slope is 1, y-intercept -1. There is your equation. If you write it like this, y equals 1 times x is just x minus 1. This is also fine. All right, guys. So this is probably the trickiest problem. Just to go over it again real quick. In order to find an equation of a line that passes through a point and is perpendicular, first you have to find the opposite reciprocal slope to this slope. So first you need this slope. This slope was 1. The opposite reciprocal slope. Opposite means negative or positive if it was negative. So -1. Reciprocal means take the 1 over. Well, 1 over 1 is just 1. So we found that. Then I had to find, to graph any equation, you need y equals mx plus b. So you need the slope and the y-intercept. So we found a slope, and the y-intercept can be found by plugging in points, right? This is your x, this is your y, plug them in, get your y-intercept, and then you'll have your slope and your y-intercept, and you'll have the equation perpendicular. Okay, let's look at 24. What's the slope of the line that's perpendicular to x equals to -4? Well, here's what I want you guys to do. If you want perpendicular, you know it is the opposite reciprocal. Okay, so I take this and I say, well, what's the slope here? I don't have a slope here. I'm not given y equals to mx plus b, where I can see this is my slope, but I'm given a line. So I'm going to go where x is -4. -1, -2, -3, -4. Right here. I'm going to draw this line. Okay, here's where x is -4. Now that I drew the line, I can see what the slope is. Sorry, it's wavy. This slope, remember, buggy goes uphill, I have positive slope. Buggy goes downhill, I have negative slope. Buggy's flat, I have 0 slope. Buggy goes straight up and down, I have undefined slope. The slope here is undefined, okay? But it doesn't ask me what is the slope of this line. It asks me what's the slope perpendicular to this line. So if this line has undefined slope, a perpendicular right here has 0 slope. So the slope perpendicular to this would be 0 slope. Okay, I didn't have this because I wasn't even in this form. I have undefined slope. That's a weird line. Draw it. So that's my hint here. Draw this. What does it look like, and what does a perpendicular look like? Perpendicular would be the horizontal, so 0 slope. All right, let's do number 25. Graph y equals to the absolute value of x minus 5. By translating y equals absolute value of x, well, absolute value of x graphs like this. Plug in points. First of all, you should know the absolute value is a v, so I can already tell you that's what it looks like. But if you're not sure, make sure you know that. If you're not sure, plug in points. Plug in 0. The absolute value of 0 is 0. Plug in 1. The absolute value of 1 is just 1. Plug in 2. The absolute value of 2 is just 2. Well, what happens to the negatives? Plug in -1. The absolute value of -1 is +1. Absolute value turns everything positive. -2. The absolute value of -2 is 2. So your graph would look like this. 0, 0. Over 1, up 1. Over 2, up 2. Over 3, up 3 if you want. And then the negatives would be -1, up 1. -2, up 2. -3, up 3. So you're going to have this V, but this is not the graph I want. I want to translate it down 5. So remember, inside the parentheses shifts you left and right opposite. Outside the parentheses shifts you up and down, straight forward. So I just take this same graph and I move everything down 5. 1, 2, 3, 4, 5. Here's this graph. So every point's going to move down 5. Every point moves down 5 from where it was. And here's my new graph. And there it is. All right. So remember, if you have y equals to the absolute value of x minus h plus k, this is a translation of y equals absolute value of x, which is just that v. This is always opposite. So if it was x minus 2, this means I would shift to the right 2. This is straightforward. This is the opposite. This is straightforward. So something like this, y equals x minus 2 plus 5, this would mean shift left 2, shift up 5. Okay. All right, that's how you do those. Go ahead and let me know if you have any questions, and good luck.